ये दिख रहा है?
जी।
यस सर।
तो ठीक है, हम लोग सो दिस इज ए केस स्टडी ऑफ से डिप्रेशन. A psychiatrist might collect data to investigate the depressant effects of certain recreational drugs. He tested 30 clubbers in all. 15 were given tablet to take on a Monday night, and 15 were allowed to drink syrup on the same day. So levels of depression were measured using the tested scale, that is Likert scale, the day after Tuesday and Friday. So let us see how we'll be doing. This is the case of independent sample test, two independent sample test. It's taking a little bit time in opening. Through this example, we will be doing one sample test as well and the two independent sample, both.
Sir, I have a query. May I
Hmm.
ask?
Yeah.
Sir, these depression is generally measured on scales and scores. So it should be non-parametric.
Yeah, that is why we are doing the examples of non-parametric.
Okay.
What
No,
you
you
are
said
thinking?
independent t-test.
No, not independent. I have not tell at all that independent sample t-test. It is independent sample.
Okay. Uh,
So the non-parametric two independent sample test is man-Whitney test. Okay. So here we have a code that say this. We have coded one as tablet and two as syrup, and so we will be comparing the two, and we can have comparison for the repeated measures as well, because we have two times data on Tuesday and data on Friday. So let us do for say one sample and another two sample. But here we are having two sample, and if you wish to have the uh, application of one sample test, then you have to partition the data in say independent sample. Okay, so then we will be doing this one, and let us do it in SPSS. So let go to analyze, then go to non-parametric test, go to legacy dialogs, and there you will see the one sample case test. So this variable we wish to check here, and then no need of that, already it is ticked out. We wish descriptive, and if you wish that quartiles as well, then you can put tick there. And now which distribution you wish to fit, only four distributions are given here, so you can fit all four distributions. But suppose we are just fitting the normal distribution only, then you can go for this one. So here this is the
Recording in
test.
progress.
Two independent sample here, and the code one is here, that is grouping variable. And here you can see that on Tuesday, the total number are 30, mean this one, and the standard deviation. But this is the combined data for all 30 persons. So this is not so much informative. We wish the data the sum of the ranks. Now come to the test statistic, the man Whitney. So you can see the two-tailed, the value is 0.203. It means the null hypothesis is not rejected because p-value is very much more than 0.05. So what we say? We say that we have no evidence to reject the null hypothesis. And the null hypothesis is that the effect of the two techniques are same. Yeah, we can say that the median score for the tablet as well as for the syrup are equal. So it means both syrup and tablet are equally effective in reducing the depression level. Okay. Now come to next.
Sir, just a small query. When
Hmm.
you did the one sample test, that was to test the normalcy of the data.
No, that was for the fitting of the distribution, not normalcy of the data. And there we have fitted the normal distribution only. But see
Okay.
here, you can fit some other three more exponential and two more distributions for there.
Means how did it help in the analysis? Means we can.
You see which one is the best fitted, say, or which one is the fitted one. Then you can have its parameters, mean, variance, quartiles, all other, so that you can get information about that. See here. These four, you can put all four distributions here, say for this one. So this way you will see which distribution is significant and not non-significant. It is non-significant. So it is not following this even normal distribution here. We have taken the Friday data here. That was for day, and that was normally distributed. And you can see here this distribution is followed by that it is uniformly distributed. And it is not Poisson distribution because it is highly significant. Now come to this one, last one, but it is also following exponential. So exponential and uniform. So this is a confusion type, but you can see here that this p value is more than that one. You can say it is more close to the uniform distribution. So this way you can have idea that which distribution is followed by the population or sample under consideration, so that you may be able to calculate its parameters, and through parameters you can make some policies or you can take some decisions.
सर ये मैन्यू टेस्ट जो आपने रन किया इस पे ये चारों फैक्टर्स यूज हो रहे हैं, जैसे कि ट्यूसडे को एडमिनिस्टर किया उसका इफेक्ट फ्राइडे को एंड सिरप एंड टैबलेट, ये चारों कंसिडर करके वो आउटपुट देगा?
चार नहीं कंसीडर करना है मैम, एट अ टाइम एक ही, नहीं तो फिर वो रिपीटेड मेजर वाला केस हो जाएगा अगर दोनों एक साथ ले लोगे। एक ही करना, वो दिखाया गया सिर्फ एक करना सिर्फ।
ओके, ठीक है।
और अगर दोनों का करना तो वन बाय वन करिए, या अगर दोनों एक साथ रख देंगे तो वो निकाल देगा तब भी।
अच्छा, ओके,
अलग अलग टेबल बना के निकाल देगा।
अच्छा, ओके।
Now come to the equivalent non-parametric test to the pair t-test, and that is Wilcoxon signed rank test. So let us see first the case study, and then we will be doing hands-on. So here is a case study of sales. A retailer wants to know the impact of print advertising on sales. He used print advertisement for 1 month period in his 10 outlets. He observed sales results before experiment and after experiment. So here, if the data is not normal, we will test the equality of medians of the two periods, before advertisement and after advertisement. So first you have to see whether the data is following normal distribution or not. So you go to analyze and descriptive statistics, and there you can go further explore, and you put say both here, and go for the plots only, uncheck this one and just put tick here, normality plots with test, and just click on OK. So first you have to check the normality. See this. So this is showing that both the tests are showing for both the variables, both the data, that the data is not normal, because p-value is very much less than 0.05 in by both the tests and for both the observations. So now let us do the non-parametric test, that is Wilcoxon signed ranks test, which is a non-parametric test equivalent to the pair t-test. So go for the two related samples. One by one you have to put here, and you can go for the options, descriptive, and no need of exact use. It is correctly ticked there, and you can see you can apply all tests, but we are interested in Wilcoxon signed rank test only. So click on OK. So these are the descriptive statistics. Now come to the test statistic. See here the p-value is 0.76. It means the p-value is very high, very much greater than 0.05. It means the null hypothesis is not rejected. So we conclude that there is no impact of print advertisement on sale. So the average means median. So average sale before advertisement and after advertisement are same. So there is no impact of print advertisement on the sale. Now come to Kruskal-Wallis test, which is equivalent to one-way ANOVA. So let us put first the descriptive statistics case study, then we will be doing hands-on and SPSS. Okay, we have a case study of coffee, very interesting case study. Scientists had discovered that the caffeine consumption linked to higher heart rate. A researcher took 40 participants and split them into 4 groups, independent, that varied in the number of caffeine consumptions. The first group was a control group and had no coffee at all per day, that is none in the whole month. The second group had 1 cup of coffee per day. The third group had 2 cups of coffee per day. And the final 4th group had 4 cups of coffee per day. At the end of the month, all of the participants were measured their heart rate scores. So let us see whether the caffeine consumption is significant in reducing the in increasing the heart rate or not. Okay. So you can see here through alphanumeric option that we have coded 1 for no coffee, 2 for 1 cup of coffee, 3 for 2 cup of coffee, and 4 for 4 cup of coffee. So, okay, now let us apply this Kruskal-Wallis test to this non-parametric test, legacy dialogues, and there you will see K independent sample test. Now put heart rate, that is continuous variable here, and you have to put grouping variable here. You have to define the range. Since we are dealing 4 groups here. So 1 to 4. And you can go for the option or no need of that. We just see the table only. Kruskal-Wallis test, or let us see descriptive only. Okay. So here this is actually descriptive statistics is not very effective here because it is descriptive statistics for the whole data containing all data of all 4 groups. So it is meaningless here. So now see, these are the ranks. You can see this is informative, little bit informative. So you can have idea that which one is going to be significant. Now you can see here the test, it is significant. Now since it is significant, so we should go for the postdoc test as well. But you can have idea from this one that this is going to be significant. So the caffeine consumption is responsible for increasing the we have no option here for actually for the so one by one we will have to check, otherwise the some postdoc test should be given here. So in non-parametric it is not given, but it is rejected. It means the coffee consumption null hypothesis is rejected. It means the median score for all type of coffee consumption are not same. And you can see here, you can see this one is 31, this is 14, 19, 16, but this one is going to be very high. So this way we can say that the caffeine consumption is effective in increasing the heart rate.
So usually heart rate should follow a normal distribution, means.
हाँ, लेकिन यहाँ पर वो किया गया है, we are just
As an example.
we have taken the data of the heart rate with the caffeine consumption. So see, these people are not say normal type. They have some higher heart rate. Or you can see, so individually they may follow for large sample, they may follow normal distribution, but their heart rate is high in comparison to other. So here just we are just calculating the median score, or says median heartbeat of the persons, 4 type of persons.
No, but means heart rate, when it follows a normal distribution, why can't we use parametric test?
No, if you have taken it is not necessary that it will follow normal distribution for smaller
The small
observations.
sample.
Sample size
For
is just
smaller for smaller observations. But here don't stick with the example. Maybe it may be parametric, but we have just taken for an example. But if the observations are very less, then may follow non-normal distribution.
On a
This
lighter mode.
in case of heart rate may be normal distribution. I accept, but we have taken just for an example.
So what do you recommend, sir? Coffee or no coffee for us?
Not everything in a limit.
Sir, between the groups, we will do the Mann-Whitney then.
Between the groups, we will do.
मतलब कि 0 कॉफी एंड 1 कप कॉफी इसमें आपस में डिफरेंस
Definitely,
लाने के लिए
since it is
अलग अलग Mann-Whitney से करेंगे.
हाँ, वो करना पड़ेगा क्योंकि इसमें मल्टीपल कंपेरिजन दिया नहीं इन्होंने, तो वो 1 by 1 0 कॉफी विद 1 कॉफी, 0 कॉफी विद 2 कॉफी, 0 कॉफी विद 4 कॉफी, जितने कॉम्बिनेशन बन सकते हैं. फिर 1 कॉफी विद 2 कॉफी, 1 कॉफी विद 4 कॉफी, 2 कॉफी विद 4 कॉफी, इतने कॉम्बिनेशन बनेंगे.
पोस्ट हॉक में कोई इसी में ऑप्शन नहीं है क्या, क्रूस वालिस में?
नहीं, मल्टीपल कंपैरिजन किसमें नहीं दिया है?
Sir, if we were to check the normality of that data set, how do we check it?
अभी तो किया था मैंने. Let me check first. You have to go to analyze, then descriptive statistics, and in descriptive statistics you will see one option, explore. लिसन वेरी केयरफुली, अगर रिपीट होगा तो बहुत टाइम लग जाता है. ये हम लोग कर चुके हैं अभी. वी हैव डन.
Sir, your opening sales data. It's not copy data.
कोई बात नहीं, कोई खोल देते हैं, इससे कोई फर्क नहीं पड़ता. इनको तो नॉर्मलिटी चेक करके बताना है. सो यू गो टू एनालाइज देन डिस्क्रिप्टिव स्टैटिस्टिक्स एंड यू विल सी हियर वन ऑप्शन, एक्सप्लोर. You just put here and go for the plots and check this one. Go this for this option, normality plots with tests, and click
Yes,
on
sir.
continue.
But for the other data set, that coffee one,
Then you
where
will have
those
to
four
extract. Then you will have to extract every group data separately. Then only
separate column. So we need to have separate columns to, that is 4 column to check the
yeah,
normality. Is it?
definitely. And
Okay, okay,
separately.
okay, okay. Thank you.
Now we come to repeated measure ANOVA equivalence non-parametric test, and that is Friedman ANOVA. So let us do this for the marketing comparison. So here we have a marketing campaigning data. To test the marketing campaign, the researcher took 15 retail outlets who considered being in need of increasing sales and putting them on this campaign for 2 months. Their sales were measured in millions at the start of the campaign, and then after 1 month, then and 2 months, 3 months, this way. We have repeated observation more than twice. Here you can check the normality by the same fashion. I'm skipping that. Then that you just go to analyze, then non-parametric test, legacy dialogues, and there you will see K-related samples. You select all and put them here and go to, you can go for the statistics, descriptive as well. And then Friedman is here, then click on OK. So these are the descriptive statistics. Median score must be there if it is not normal. So there is no need of mean score, there is need of median score there. So you can see mean ranks, we can see. So here you can see that see the p-value is 0.766, very high, very high in comparison to 0.05. So it means there is no impact of campaigning on the sales. Null hypothesis is not rejected. Now very quickly we come to that chi-square test. See here we have two attributes, that is gender and education, and here we wish to check whether education is gender specific or not, or alternatively we wish to check that education and gender two are independent attributes. So let us do it. So you can do it through two ways. One, you go to analyze, then descriptive statistics, and there you will see this cross tab. And you have to put this one variable here and another one here. And there are so many options you can put for the statistics. So here you have to check chi-square. And if you think that you should get some more statistics, then you can put check there. Otherwise, no need. And you just go, okay, no need. You click on OK. So here you can see chi-square test is saying that through different tests that that the test null hypothesis is not rejected. It means the two attributes are not associated to each other. They are independent to each other. He is Galton. So this way here we can establish a relationship between, see, in correlation, we don't talk about the dependency of the variable and independency of the variable. That is, we do not talk about which one is dependent and which one is independent. But we do talk about the dependent variable and independent variable in regression analysis. So here we have, say, yield and fertilizer. So yield depend on fertilizer. So fertilizer, we can increase and decrease the fertilizer, and it will impact that yield. So we have a relationship between yield and fertilizer this way, that yield is a function of fertilizer. So this way we can make the function relationship between two or more variables. These are some basic properties of regression coefficients. What is the regression coefficient? In line, say y equal to a plus bx, b is the regression coefficient which tells about the change in y with the unit change in x. So regression coefficient always tells the change of the corresponding independent variable, change in the dependent variable with the corresponding change in the independent variable, unit change in the independent variable. Suppose we have more than one independent variable. So in multiple linear regression, y equal to a plus beta 1 x1 plus beta 2 x2. So beta 1 is telling how x1 is impacting y. So how, if we are changing x1 by unit, so by which rate y will be changed. So beta tells about the rate of change in y with the unit change in x. And these are there are always two regression lines, y on x and x on y, because sometimes we are very confused which one is dependent and which one is independent, because both are impacting to each other. So there are always two regression lines. So here this b x y is known as, this is x on y. It means x is dependent here and y is independent. And by on x, by on x means y is dependent and x is independent. So the correlation coefficient is the geometric mean of the regression coefficients. And see, if one regression coefficient is, its limit is from minus infinity to infinity. See, if one regression coefficient is greater than 0, then another one is always less than, sorry, greater than 1, then another one is less than 1. And the average arithmetic mean is always greater than or equal to and the correlation coefficient. So these are some properties of the regression coefficient. And see here, this one. So this is the regression coefficient. This is x on y. So here x is dependent variable and y is independent. While here y is dependent and x is independent. This is intercept term. It means if we have no change in x, then what is the value of y? ऐसा मान लीजिए, suppose we are starting some business, so there is need of some investment before profit. So this B is telling about the profit, but this is the initial investment to get the profit. So this A is the interceptor. So this way you can calculate through calculations, through the formula that regression coefficient is nothing but covariance divided by the variance of x, which one is the independent variable. So these are the normal equations. I am not going into the detail because many of you are not of mathematics background. So we'll be doing hands-on. These are some examples and we have calculated. See, this one is the regression coefficient and this is known as the covariance between x and y, and this is the variance of y because here y is independent and here x is independent, so it is the covariance of xy upon variance of x. So this way we can calculate the regression coefficient and then we can make the complete line this way. We have to calculate the intercept term as well as the regression coefficient. So this is the regression coefficient, this is the intercept term. So this is the line now for the particular data. Now, if you put some x, then you will find the value of y. Suppose we have some data of say yield and the area of some area. So we have established the relationship between area and production, yield and area. Now, if someone comes and of that area, particular region comes and that I have of say 50 bigha, that 50 acre or like that area, then what will be the production of the particular crop? So you will be able to tell the person that you will get that much of yield because you have the estimates of the coefficient. Just you put the value of x as 50 and then you will find the value of y. So the beautiful part of this regression analysis is that it has the capability to predict the things. Sorry, not only analyze the things, it is having capability to predict the things. That is why in statistics, 60 to 70% of the statistics is, I personally accept that 70% of the statistics is regression. Everywhere you will see regression. If you are using design of experiment, modeling is there. If you are using time series, that is regression analysis. So regression is there. So I think 60 to 70% of the statistics is that regression analysis. See, someone was asking about the statistics which should be used at different situations. So this is the table. Through this, you can see which table, which particular statistics should be used at which situation. So you all will get this one. So this was our today's discussion on regression. Let us do the hands-on. And then we will be entertaining the questions. We have data description here, bivariate and multivariate regression. So we'll consider the case. So here this is bivariate means two variables only, one dependent and one independent variable. So here these are the salary. So these are the data, so much data, and then and these are the number of years of experience. So we will see that salary depends on the experience. So experience may decrease, increase. Obviously, since it is time, so it will increase. So this is independent variable and salary is dependent variable. So we will be looking for the relationship between the two.
Sir, is bivariate regression done only when the dependent variable is continuous?
Both are continuous, ma'am. Regression is only applied when both dependent and independent variable are numeric.
Okay, sir. So only for continuous variable will be doing regression.
Yeah.
Okay, so what about the categorical chi-square only?
If both are categorical, then chi-square. If y dependent is categorical and independent is numeric, then logistic regression is used.
Okay, okay, sir.
So you just click on analyze and go to regression, and you can go for any. Say, see, there are so many regression. So you go for the linear regression. So dependent variable is salary. Independent variable is here. And you can select the method, stepwise regression. And you can go for the statistics. So many statistics you can have. And Darwin Watson is not required here, because if it is time series data, then it is required. Click on continue. You can go for the plots if you wish, histogram, and you have to put the variables first define. And you can save the observations. You can go for the options as well. But no need of that. You just click on OK. See here. These are the coefficients. See, the regression coefficient of significant, they must be significant. If they are not significant, it means it is not contributing. The independent variable is not contributing at all to dependent variable. So the coefficients should be significant. Now you can see here, these are the coefficients. This is intercept term and this is the regression coefficient, and both are significant. So you can make the model or regression line that y is equal to this one constant term plus this into x. That is number of years of the experience. But then you can put, now a new person came with some experience, then you can select its salary. You can decide its salary through this model. Now see here, R square is 0.6. Not very good. It means we can search for some more better model, because the coefficient of determination is not very high. It is only 0.6. It means this data or this model is capable to explain the 60% variance in the data. 60% variation in the data only. So we can go for some more models as well. Now come to another example with multiple regression. A national company is a books publishing company. Each data set is assumed to be based on survey of national customers completed by personal interview. The primary database consisting of 120 observations and 20 questions is based on a market segmentation study of national customers. National sells books to two market segments, the education institutions and the booksellers. There are two, educational institutions and the booksellers. The information was perceptions of national's performance on 15 attributes. Respondents of educational institutions and the booksellers buying from national, and they rated national on each of the 15 questions using 10-point scale, with 10 being excellent and 0 being very poor. ये क्वेश्चंस उनसे पूछे गए. National company uses online services. This company provides e-materials to the teachers and this way. So let us see. See here, we have many qualitative type questions. So now you can go for the multiple linear regression. So you have to choose the questions as independent variables, and some you have to select the independent variable. We have these categorical variables as well. So now let us do it. Just go to analyze, then go to regression, and then you should go for this one, linear. Now you have to decide here which one is going to be dependent variable. But in case of multiple comparison as well, we should check any of the dependent one should be dependent one should this dependent should also be the numeric one. So either you put any one of them, say, but here we have taken it as it is not going to be a very good example for say, because it is categorical, but it is still we wish to put and go for the stepwise regression and click on OK. So this see warning is there because we have taken one non-numeric one. So let us remove it. Go to analyze linear regression. Then you will have to select, say, you remove it and just put first question here and first here. Now it will do with the multiple. You can see here, these are the coefficients and these are the excluded variables. Stepwise regression tells that one by one we will add the independent variable and we will see the adjusted R square. So it will tell whether the addition of the new variable is capable to enhance or to contribute to the dependent variable or not. So this way we will see that R square, adjusted R square is again that 0.6, only 60% of the data is explained by this. So all these variables are excluded from that analysis. So these are not, I mean, they do not contribute to the dependent variable. So this way you can select the multiple linear model as well. You just put dependent variable in dependent group and you can put all independent variables in independent variables column. So this way.
So can you tell once more, what does that R square value signify?
R square tells about that which model you have fitted, how much of the variation is explained by the model. If say it is the R square is 0.9, it means 90% of the variation of the data is explained by the model. So it is a little bit good. But if it is 0.6, then 60% of the data is explained by the model and 40% of the data is that the model is not capable to explain that one.
Okay, sir. Is there any optimal level for that or value?
One, maximum
No.
one, best fitted
Okay.
one.
Okay,
0 to
okay.
1. It will lie from 0 to 1.
Okay, sir.
So,
Sir, this
explain that output, sir, again, please.
Which one?
The output of this analysis.
Say we are considering that bivariate.
Sir, this value of R decides the correlation is positive or like negative.
This is multiple correlation. Actually, we are using more than one independent variable.
Yes, sir.
So R is multiple correlation coefficient here, and R square is the square of that, and that is known as coefficient of determination. It tells about how good the model is fitted to the data.
Means more
How to
nearer
say
to one
that?
it is, then we can say that data is like
Yeah, model is good fit to the data.
good fitted.
It is close to 1.
Sir, I wanted to ask, like, out of these various independent factors, which one, how do you grade those factors from this analysis?
Which one? How
How
independent
to,
step,
huh,
if
there,
using
there's
stepwise
so,
regression, if we are
huh,
using stepwise regression and we are looking for the good value of R square. If R square is not enhancing, it is not approaching to 1 and we keep on adding the independent variables, then the model is not going to be good. It means the variables are not, related to that Y. So that they may change in Y with the change in itself. So they may be independent of that, but they must be dependent of that.
no, so
Sir,
my
जैसे
question
यहाँ
is, in that analysis, we have taken so many factors, independent factors. How
Yeah.
do you rank these independent factors? Okay, this is contributing more to
No
the
need,
dependent.
no need of ranking, ma'am. They are independent. They are independent to each other. There is no need to rank them. But if you wish to check whether they are associated to each other or not, so there is a factor if whether independent variables are linearly related to each other or not. This is known as the case of multicollinearity. So we check that through the multicollinearity test. So
Okay.
you think na you should, the investigator should check how many variables are going to contribute to dependent variable or not, and that is why we use this stepwise regression. One by one, it add one by one independent variables to the model. That is why we use this and it uses addition and separation of the model. So many independent variables are rejected from the model. They suggest that they should not be included in the model because they are not contributing to the dependent variable.
Okay. Yes, sir. Show that in the output, sir, please.
See here, this one. Since here only one independent variable is in this case, so we have no addition and separation of the or deletion of the independent variables. At least we should have at least two independent variables.
No, the last
Sir,
one you
if
had told there were multiple independent variables.
Yeah,
That-
multiple.
sir, if we have 100 observations, we have to do it 100 times with stepping out one, stepping out.
100 नो ऑब्जर्वेशन नहीं, वेरिएबल्स होने चाहिए. ऑब्जर्वेशन तो एक वेरिएबल पे भी आप 100
Yes, sir.
ऑब्जर्वेशन ले सकते हैं.
100 variables there means we have to do one by
So
one.
automatically it will do. अब अगर मैनुअली करना है तो वही है. If you are doing manually, then one by one. First, you will take one variable, say, and you will fit a model y equal to beta naught plus beta 1 x1. And you will see how much is the R square. Then you will add another one plus beta 2 x2, and you will see the now what is the value of R square. Then third one, fourth one, and this way you can see which variable is going to contribute to the dependent variable or not. In stepwise regression, we do this one.
Sir,
Sir,
in automatic, how we do automatic way?
वो तो सॉफ्टवेयर में भर दीजिए, सारे वेरिएबल डाल दीजिए, ऑटोमेटिकली इट विल डू. Which are important, which are not important, it will separate them out.
Sir, can you do it for the case study you just shown?
Yeah, we have done it. See here in this case. See here, we have so many variables.
Yes, sir.
Okay. So let us do it this way that we go to analyze, then regression, and then go to linear. You say this 15th question is the dependent one, and say these all are independent. 14 questions. You put them here, and just we have used this stepwise regression. Okay. Then just click on OK. So you will see variables entered oblique removed, which are these are entered, and these are the removed, you can see. So this way you can have which are going to be significant or not. Here no one has been removed. All are entered, say here. No one is removed. But this is the model with the 1, 2, 3, 4, 5, 6 independent variable only. So dependent variable is 15. I am satisfied with the national company, and these are the independent variable. So it has entered only, see, 6 variables out of 14.
15 variable. 14 variable.
Yeah, out of 14. So this way, and this is the summary. Then again, it has made Innova. So out of 14, it has taken only 6. So 8 are not considered. They are not.
So why, sir?
Hmm?
Why are only
They are
6?
not, actually, they are not capable to change. They are not related to that one.
Okay.
That is
So
why
how do
they
you,
have been removed.
yes, sir. How do you interpret that beta, sir, here?
Beta coefficient tells
Is
about by which rate the
okay.
independent variable is doing impact on dependent variable. By which rate it is changing. Beta
Okay.
tells the rate only, rate of change.
So can we say like all those like independent variable which have come significant, they are having an impact on the dependent variable?
Yeah.
Okay.
If the variable that coefficient is significant, then see here, these this is not going to be significant. This is going to be significant. By which rate it is impacting? It means if we are doing one change in X, then it is 0.39, it will change to Y. By this rate.
Okay.
This with respect to 1.
These are excluded variables.
इसका मतलब ये अगर हम एक चेंज कर रहे हैं, we are changing by 1 this unit paper quality, then it will have 40% change in Y.
Okay.
Almost 39. अब केस स्टडी बताइए, देखें किसका क्या है.
सर स्टार्ट करें.
हाँ बिल्कुल.
ये एक केस है. रिसर्चर विश टू फाइंड, एनीबडी कैन आल्सो कमेंट आल्सो, विश टू फाइंड द यूटिलिटी ऑफ ड्रग A, B and C in 450 पेशेंट्स विद हेडेक. तो हेडेक में उन्होंने 3 ड्रग दिए, 450 पेशेंट्स को डिवाइड किया. Patients were followed at 1 month, 2 months and 3 months after starting therapy. और response जो था, they measured as more than 50% improvement in number of headache days. So good response or bad response means no response or good response from baseline frequency. Now researcher wants to find out the difference in response to treatment, these 3 different treatments at 1 month, 2 months and 3 months after treatment. तो इसमें 3 ड्रग्स दिए 3 महीने के लिए अलग अलग, और रिस्पॉन्स का डेफिनेशन ये दिया. So it will be good or bad. तो what I thought is कि हेडेक डेज जो है वो नॉर्मल डिस्ट्रीब्यूशन, मतलब किसी को कितने दिन हेडेक होता है, किसी को कितने दिन होता है, तो हम पहले नॉर्मल डिस्ट्रीब्यूशन चेक करेंगे एंड देन वी कैन अप्लाई पैरामीट्रिक टेस्ट. And then if it is following normal distribution, then one-way ANOVA can be used for the 3 groups A, B, C.
3 groups and 3 drugs, ना?
3 drugs. 3 groups 3 drugs भी हैं. हाँ नहीं सर, ग्रुप्स तो अलग अलग.
ग्रुप्स तो चलो इंडिपेंडेंट हो गए, उससे मतलब नहीं.
हाँ.
क्या एक तो किया है आपने 3 टाइप्स ऑफ ड्रग्स यूज किया है.
हाँ.
दूसरा क्या किया है,
और 3 महीने,
3
एक
टाइम्स
महीने.
है.
हाँ.
रिपीट किया उनको कि 3 months रिपीट किया है. ठीक है, वन वे वो रिपीटेड लगा दीजिए उस पर.
हाँ रिपीटेड, या फिर हम सेपरेटली भी कर सकते हैं,
अलग अलग कर सकते हैं.
अलग अलग. तो इसमें सर काई स्क्वायर लगा सकते हैं.
काई स्क्वायर तो एट्रीब्यूट के लिए चेक होगा. यहाँ पे कहाँ एट्रीब्यूट है आपके पास, न्यूमेरिक ऑब्जर्वेशन सब.
हाँ एट्रीब्यूट जैसे येस और नो है, जैसे गुड रिस्पॉन्स और बैड रिस्पॉन्स है.
हाँ उसके बीच में नहीं, काई स्क्वायर तो वो हो गया ना आपका, बैड रिस्पॉन्स और
गुड
गुड
रिस्पॉन्स.
रिस्पॉन्स.
तो 1 month पर 3 ड्रग्स हैं, we can see good response, bad response at 1 month
हाँ
between
बिल्कुल
the three
बिल्कुल,
drugs.
आप ये इस पे ये लगाएंगे कि क्या रिस्पांस जो है ड्रग डिपेंडेंट है कि नहीं, तो का स्क्वायर लगेगा।
तो काई स्क्वायर लग सकता है, तो दोनों लग सकते हैं, अनोवा भी
हाँ
और काई स्क्वायर।
ये अलग लगेगा, ये अलग लगेगा, रिस्पांस के लिए ये लगेगा।
अनोवा, सर अनोवा नहीं लगेगा बिकॉज इट इज क्वालिटेटिव आ रहा है ना वो डिपेंडेंट वेरिएबल, तो
डिपेंडेंट वेरिएबल,
क्वालिटेटिव आ रहा है ना
डिपेंडेंट वेरिएबल क्या है आपका?
यहाँ पे है ना 50%, तो ये इट विल बी यस और नो, समथिंग लाइक दैट ना, इट विल बी क्वालिटेटिव, इट इज नॉट न्यूमेरिकली, तो एनोवा नहीं लगेगा ऐसा मुझे लगता है।
नहीं तो अरे तो कोई दिक्कत नहीं, वो लगा दीजिए ना आप, क्या नाम, यहाँ डिपेंडेंट वेरिएबल आपका वो हो गया।
फ्रीडमैन या क्रूसवेलिस?
नहीं, क्रुस्काल वैलिस की बात नहीं है, अगर डिपेंडेंट वेरिएबल आपका कैटेगरिकल है और इंडिपेंडेंट वेरिएबल्स न्यूमेरिक हैं तो लॉजिस्टिक रिग्रेशन लगता है।
ओके,
बट
तो
यहाँ
सर
50 नहीं, वो एनोवा आप परफॉर्म कर सकते हैं, अगर बैड गुड को ना लीजिए तो केवल
हाँ,
आपस में कंपेयर करिए उनको
डेज
ड्रग्स।
ले लें तो
हाँ, और जब उसको ले रहे हैं तो ये काई स्क्वायर लगा के कर सकते हैं और लॉजिस्टिक वहां पे लगा सकते हैं। फिर
लॉजिस्टिक क्यों लगेगा इसमें?
दो ग्रुप आपके हो गए, इफेक्टिव और नॉट इफेक्टिव,
हम्म
ठीक है, और ये
जी,
इनकी सबकी न्यूमेरिक वैल्यूज मिल जाएंगी डिफरेंट ड्रग्स की या डिफरेंट मंथ्स की, देन यू कैन अप्लाई, तो वो प्रोबेबिलिटी बता देगा कितना चांस है कि ये किस ग्रुप में जाएगा, इफेक्टिव में जाएगा कि नॉन इफेक्टिव में जाएगा।
ठीक है। और इसमें सर जैसे अगर नॉर्मल डिस्ट्रीब्यूशन नहीं भी शो करता है तो हम आउटलायर्स को निकाल सकते हैं, क्योंकि
हाँ निकाल सकते हैं, और नहीं अगर वो इम्पोर्टेंट नहीं निकालना चाह रहे हैं तो
तो
क्या
फिर
हुआ,
से
उसका जो ये वन वे लगा रहे हैं तो उसकी जगह क्रुस्काल वैलिस लगाइए, क्या दिक्कत
तो ये ठीक है फिर एनालिसिस।
है। बस लॉजिस्टिक एक और ऐड कर सकते हैं इसमें।
जी ठीक है। ऐसे ही ये थोड़ा सा अलग है उससे, इसमें रिसर्चर विश टू स्टडी रोल ऑफ ड्रग ए, अब एक ही ड्रग है और वो किसी टीबी में प्रिवेंट करने के लिए किसी चीज को दिया हुआ है, और दूसरा प्लेसिबो है, मतलब और यहाँ पर रैंडमाइज कर दिया 30, वन ग्रुप वॉज गिवन ड्रग ए एंड अदर प्लेसिबो, और अब
3 मंथ
उसको
तक दिया गया डेटा है तो टी टेस्ट ही लगाइए।
सर इसमें टी टेस्ट प्रोपोर्शन ऑफ पेशेंट्स है,
क्या
मतलब
प्रोपोर्शन लगा रखा है, ठीक है।
हाँ, तो प्रोपोर्शन ऑफ पेशेंट्स जिनको ये प्रॉब्लम हुआ और जिनको नहीं हुआ, तो मान लीजिए
ऑड्स रेशियो निकालना पड़ेगा इसमें।
इसमें भी काई स्क्वायर लगेगा ना सर?
हाँ, एट्रीब्यूट जहां होगा वहां सब का स्क्वायर ही लगेगा, बट इसमें आप ऑड्स रेशियो भी निकाल सकते हैं।
तो अच्छा, तो ये कैसे डिसाइड करेंगे कि कौन सा लगाना चाहिए?
नहीं, ऑड्स रेशियो तो आप निकाल के खुद ही देख लेंगे, पता चल जाएगा कि किसके रिस्पेक्ट में कौन से कितने ऑड्स हैं, कितना फेवर में है।
वो हाँ, आप पैक स्क्वायर लगाते हैं ना, उसी में वो ऑप्शन आता है इवन
हम्म
फॉर कैलकुलेटिंग ऑड्स।
राइट। और दूसरा, ये तो फर्स्ट पॉइंट तो क्लियर है सर, दूसरा जो है उसमें है कि डिजीज सिवियरिटी स्कोर, वो एक स्कोर है, वो एक नंबर है, वो बेसलाइन और 3 मंथ्स पे कंपेयर कर रहे हैं, मतलब दो दो ड्रग्स हैं और दो बेसलाइन और 3 मंथ्स है, और चेंज देख रहे हैं सिवियरिटी स्कोर। मान लीजिए पहले स्कोर ए ग्रुप में 30 से 20 हो गया, सेकंड ग्रुप में 30 से 10 हो गया।
अगर देखिए, अगर ये चेंज दोनों के लिए निकाला है आपने और वो चेंज जो है वो है क्या नाम है, न्यूमेरिक है, तो टी टेस्ट लगा के कंपेयर कर लीजिए कि क्या दोनों में मीन चेंज वो बराबर है कि नहीं।
तो मीन चेंज मतलब सभी जो सारे ऑब्जर्वेशंस हैं
हाँ,
उनका।
उनके लिए एवरेज चेंज वो बताएगा। अब एक एक के लिए चेंज तो नहीं, हमेशा हम तो बात ऑन एवरेज ही करते हैं ना स्टेटिस्टिक्स में, और करना भी चाहिए, जनरलाइज करना है अगर आपको।
तो वही लिखा था कि उसमें तो
कोई नहीं,
क्योंकि
आपने
मेरी
मैन विटनी लिखा है, अगर नॉन नॉर्मल होगा तो मैन विटनी लगा दीजिए, इक्विवेलेंट उसी के तो है टी टेस्ट के, इंडिपेंडेंस। ठीक है।
ठीक है सर, तो ठीक है, इसका मतलब समझ में आ गया। ठीक है
गुड।
जी, थैंक यू सर।